So this is the 52 paper. I hope you guys managed to download this. If not, I will. Yeah. Did anyone manage to download it? Okay. Maybe if you can circulate that amongst the others after this, that'd be great. Okay. So we'll go on to the first question. All right. So we've got random variable x takes these values. So these are the values it can be. And it's given that the probability of a particular value of x is given by this formula here, k, into x squared minus 1. And we know that k is a constant. And we've got to draw up a probability distribution table for x. And we need to give the probabilities as numerical fractions. Okay. So step 1, what are our possible values of x? Well, we're given them up here. There's only 3. So minus 2, 2, and 3. And then we've got to use this information here to construct the probabilities. So if x is minus 2, well, what's minus 2 squared? 4. Take away 1 is 3, so 3k. And then if we chuck in 2, we'll get the same result again, so that's 3k. If we chuck in 3, that's 3 squared. Subtract 1, so 8k. Now, altogether, if we add the k's up, we can see that we've got 14k is equal to 1. So, why does it equal 1? Anyone want to have a crack at that? Don't be shy now. Jess, what do you reckon? Yep. And those are the only possibilities. So therefore we can say that k equals 1/14. Now there's one more thing that we need to do to finish this question off, because we haven't done exactly what we've been required to do. And that's this last bit here. We've got to give the probabilities of numerical fractions. So I'm going to give my results as 3/14, 3/14, and 8/14. And that will be fine. Oops, don't know what happened there. I don't know why that's doing that. Whoops. Okay, fine. We'll just ignore the little random bracket there. Let's move on. Okay, find EX and var x. Okay, so EX, what do we need to do for EX? Draw party? Okay, so for example, minus 2. Cool. Yep. Okay. And so we can see that we're going to get 24/14 because the first two cancel each other out, or I guess we can rewrite that as 12 sevenths. Okay, now var x. Tash, what are we doing for var x? Yep. So minus 2 squared times 3/14 plus 2 squared times 3/14 plus 3 squared times 8/14, and then subtracting the mean squared, which we found in the previous part. So this one squared. And we can chuck that into our calculators. Now, when I did this before, I got 192 over 14. All right. So there's our first question. I think it's quite a nice, easy one to start off. Okay. Okay, next one. Sports event is taking place for 4 days. Beginning on Sunday. Okay, so starting on Sunday. The probability that it will rain on Sunday. So rain on Sunday is 0.4. On any subsequent day, so subsequent means the following days, probability it will rain is 0.7 if it rained on the previous day, and 0.2 if it did not rain on the previous day. Okay, and so we have to find the probability that it does not rain on any of the 4 days. So in other words, it's fine for every day. So we want fine, 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 fine. Okay, so what's the probability that it's not going to rain on the first day, that it's fine? Well, obviously 0.6. And then on any subsequent day, the probability that it will rain is 0.7 if it rained on the previous day. So that's not what we're doing because it didn't rain on the first day. Or 0.2 if it did not rain on the previous day. Okay, so this 0.2 is talking about if it rained, if it didn't rain on the previous day, what's the chance it will rain on the next day? So therefore, the chance that it won't rain on the next day is 0.8. And since each day after that is fine, we're going to have 0.6 times 0.8 cubed. So 192 over 625. Okay, and then the next one, find the probability that the first day on which it rains during the event is Tuesday. Okay, so we started off, I think, on Sunday. So we want Sunday, Monday, Tuesday. So we want fine, fine, rain. So again, fine on the first day is 0.6. Fine on the second day if it was fine on the first day is 0.8. Now, what's the chance that it rains if it was fine on the previous day? 0.2 if it did not rain on the previous day. So I think we want to times by 0.2 here. And when we pop that into the calculator, we get 12 over 125. Everyone tracking? Is this okay so far? Any questions? Just feel free to button if you've got a question. All right. Moving on then to C. Find the probability that it rains on exactly one of the 4 days of the event. Okay, so let's think about the different ways. So just one of the 4 days. So we could start off with a rainy day. So that would be rain, fine, fine, fine. Or we could go fine, rain, fine, fine. Or we could go fine, fine, rain, fine. Or we could go fine, 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 rain. Okay, those are the only possibilities of having one rainy day. Now, if we get rain on the first day, going back up here, it's 0. Probably it will rain on Sunday is 0.4. Okay, so we're starting for the 0.4. So 0.4. And then on the next day, the probability that it will rain is 0.7 if it rained on the previous day, which means it's 0.3 to be fine on the second day. So this is times 0.3. And then if we go back up, now we're on a fine day. What's the probability of it being fine on the next day going to be? Thomas? Yeah. And so it'll be 0.8 on both of those last 2 days, won't it? Because it's 0.8 if the day before was fine. Okay, so this works out to be 48 over 65, I think. Now this next one, to start fine is 0.6 as before. And then what is it to be rainy on the second day? I think it's 0.2, isn't it? Looking at that, it looks like 0.2 to me. And then for us to get this fine day after a rainy day, remember we just talked about that before, a fine day after a rainy day is going to be a 0.3. 0.3, and then we've got a fine day after a fine day, which is 0.8. So plug that into the calculator, we get 18 over 625. Next one is fine, fine, rain, fine, so 0.6. And remember, a fine day after a fine day is 0.8, so we've got 0.8 there. Then we get our rainy day. So a rainy day after a fine day, we've already discussed that, is 0.2. And then a fine day after a rainy day is a 0.3, which we also discussed. Now, if we plug this in to the calculator, I was getting 18 over 625 again. The next one is fine, 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 rain. So 0.6. Fine day after a fine day is 0.8. And we got two of them in a row. So 0.8 cubed. And this last one is a rainy day after a fine day, which is, I think that's our 0.2 again, isn't it? Yes, that's this bottom bit here, 0.2 if it did not rain. Okay, so we want a 0.2 there. And this gives us 48 over 625. Now, therefore, the total is going to be all of those added together. And when I add them together, I was getting 132 over 625. Any questions on that one, or is everyone happy? Going once. Going twice. Sold. All right. Next one. Right, what have we got here? Stem and leaf. Monthly salaries. Dollars. I've got 27 employees. Two companies A and B. I've got a key. We want to find the median and the IQR for company A. Okay, so if there's 27 employees, what's the median employee? What one are we going to be looking at, Vinay? Okay, so we're going to count and find the 14th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, I think it's this one here. This should be our median. Okay, what about... what are we going to do now, Tino, to find our lower quartile? Okay. 1, 2, 3, 4, 5, 6, 7. So this is our lower quartile. Another way of thinking about that, that's great, Tino, that's real good, is if you've already found your median, you've now got 26 employees, right? And so you can split those into 13 and 13, and halfway in 13 is the 7th number because you've got 6 on either side of it, okay? All right, we'll do the same from the top. We go back 7, so 1, 2, 3, 4, 5, 6, 7. So I think this is the 7th here. So now I'm going to write these values. So median is, oh, and now make sure we write it as salaries, okay? So look at this. So I want 2710. No, sorry, 11, isn't it? My apologies. $11. Okay, and then the IQR is equal to the upper quartile. So what am I going to write for the upper quartile there, Jess? Do the whole equation. Perfect. Very good. And then, look, I'm not going to waste time with this too much. So they give you the all of the data that you need for drawing box and whisker plots. The only thing they haven't mentioned here is the top and bottom values, which is where your stems. Yeah, raw putty. Yep. Yeah. Okay. Cool. All right. So I was just using this key here. So 27. Oh, my apologies. I think I did stuff it up. I was right the first time. Looking at the key, looking at the key, 27.1 means 2,710. Okay, and then 27.6 means 2,760. So you're right to question me there. Well done. Yep. Yes. Yes. Yeah. Let's say, for example, we had something like, um, okay, uh, okay. Um, let's say we've got. You can see that there's 6, isn't it? 6. So we've got 2 middle numbers, right? So 1, 2. These would be our 2 middle numbers. So in this case, it would be 35 plus 36 divided by 2. So 35.5. Is that answering was that the kind of question you had, Jess? Okay, cool. Good spotting, Ropati. Let's move on to just quickly chat about this one. So for this box and whisker stuff, the only other data that you need, they've given you median, upper and lower quartile, and you've found median, upper and lower quartile for company A. You just need to look at these bottom numbers, right? And then these top numbers, and that would be the end parts of your stem, because you've already got your box data from here. Is everyone kind of fairly happy that we don't need to spend too much time on that? If we just move on. Yep. And just think carefully about your scale on this. So I will say what I did for the scale. I started on 2, 400, and I just went up 100 each time. All right, like that. That was my scale. The only other thing that we need to look at here, and I thought it was quite an easy question, comment on whether mean would be more appropriate measure than median. Okay, so look at the data you've got, and you'll probably would have noticed, hey, look at this value here, and what do you notice about the rest of the value? Right, the rest of the value is lower. So this is what we would say is an extreme value. So in this case, I think we'd say that the median would be the best central value, because the extreme value for B would distort the mean. Okay, that's all you'd need to say for that one. Okay, let's move on. All right, so a fierce 5-sided spinner has size labeled, helpfully 1, 2, 3, 4, 5, and we spin repeatedly. Oh, as soon as you see this, what are you thinking, Matthew? Yes, correct. Until we get a 2, and the random variable notes the number of spins required. Okay, so we've got to find this, which means what's the probability that it takes 4 times to get a 2? So this means that we've got to fail 3 times and then succeed. So, Ropati, what am I going to pop in, do you reckon, here for my equation? Okay, we want to get a 2. What's the chance of failing to get a 2? That's the chance of getting a 2. So the chance of failing to get a 2 is 4/5, right? So we want to fail, 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 and then on our fourth time we get it. So that would be this, okay? Which if we plug it in, we should get 64? 64 over 65. Okay, now this one here, probability that x is less than 6. So in other words, that it takes less than 6 turns for us to get it. Tash, what would you do in this situation? Yeah, which one is it? It is 5. Yep. Okay. Because if we want it less than 6 times, that means if we fail 5 times, that would mean it has to be at least 6, doesn't it? But we want less than 6. So if we find what's the chance of it being 6 or more, that's 5 fails, right? Because if you fail 5 times, you've got to keep going until you get a 2, which, right? So if we go 1, take away that, we should have the probability of it being less than 6 times. Now, yep, Thomas. Yes. So if it was less than or equal to 6 times, then you would do to the power of 6, because it could equal that. This is giving me maybe check this. 725 2101. So I think it's right. Yep. Alrighty. And then we have 2 fair spinners. We've got 2 of them, and we're spinning them at the same time. If the numbers are obtained are equal, the score is 0. Otherwise, the score is the higher number minus the lower number. Okay. And then we find the probability that the score is greater than 0 given that the score is not equal to 2. So this is conditional probability. And to be honest, what I would do for this is I'm going to draw a sample space diagram because I think that would be the easiest way to answer this. So we're going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then we just pop in our values. Okay, maybe do all the different colors so I don't get confused. Okay, when the scores are equal, we get a 0, and then apart from that, we get the difference between the scores. So 1, 2, 3, 4, 1, 1, 2, 3, 2, 1, 1, 2, 3, 2, 1, 1, 4, 3, 2, 1. Okay, I think that's right. All right. So we want the probability that we've got a greater than 0 result given that the score does not equal 2. That's what we're being asked. So I'm going to write this in our probability language. So probability that it's greater than 0, intersection doesn't equal to 2. And then over, what should be on the bottom of this, Thomas? Okay, so there we go. Now, what's the probability that it's greater than 0 and not 2? So you can see all the ones greater than 0 and not equal to 0. 1, 2, 3, 4, 5. Oh, wait, not that one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I think it's 14 out of, what's that, 5 5 is 25. So 14 over 25. And then on the bottom, not equal to 2. It might be easier to count the 2s and subtract from 25. Where are the 2s? Got a 2 here, got a 2 here, got a 2 here, 2. Okay, we've got 6 of them, eh? So was it 6 off 25, 19? So we could say this one is 19 over 25. And then they cancel out, don't they? Leaving us with 14 over 19 is our answer there. Everyone happy with that question? Any questions about that question? I think doing the sample space diagram made it easy. All right. The two spinners are spun at the same time repeatedly. Someone was bored. And for 9 randomly chosen spins of the two spinners, probability that the score is greater than 2 on at least 3 occasions. Okay. Tino, what are we using here? What does this seem like to you? Legend. Okay, yes, it's binomial. So we write out X is binomially distributed. How many trials are we doing, Tino? What's the probability of success? We can go back to our previous... Oh, yeah, say again? Yes, that's... wait, hang on. Greater than 2. Is it 19/25, is it? Greater than 2? I'm going to go back and have another look. I'm going to highlight with green. Where is it greater than 2? Here, here, here. Here, here, here. What do you think, Tino? Yeah. It wasn't what we had done before, actually. 6/25. Okay, good. All right. Now, there are a couple of ways of doing this. Vinayak, what's the easiest way of doing this? Yeah, that's exactly right. So, finding it greater than 2, but instead of doing 3, 4, 5, 6, 7, 8, 9 occasions, we're going to do 0, 1, and 2 occasions and subtract that from 1. Is that what you were meaning? Yeah, okay. So we're going to go like that. So do you want to do that for me then, Vinay? What am I going to have in my bracket? Yep, very good. And what do we get there? Maybe just plug that into your calculators because I can't read my handwriting. Anyone got it? Probably easier to use decimals. I get 0.371. Can anyone confirm? Yep, we got a confirmation. Perfect. All right, everyone happy with that question? Cool. All right, let's move on. Oh, wow. The lengths of western bluebirds are normally distributed. That's helpful. Mean is 16.5, standard deviation 0.6. Random sample of 150 of these birds selected. How many of the 150 birds would you expect to have a length between la 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 la? Okay. What's the first step that we're going to take here, Jess? And then probability. Okay, and then no. It is, yeah, it's already normally distributed. Yep. We could find the Z number. Well, we have to find the Z numbers, okay? To be able to use the table. So I'm going to say Z1, and I'm going to use that for my 15.4. So complete the table. What am I going to write next, Matthew? Z1 equals? Okay. And negative 1.83 recurring. Z2, we'll do the same with the other one. Hello, Mia. Do you want to try this one, Mia? Oh, no microphone. Okay. Were you here before, Mia? I hope I wasn't just ignoring you. I only just noticed you now. Okay, alright. Fine. Okay, so we're going to go 16 point... Yeah, Roll Party. Yeah. Uh-huh. That gives us 0.3 over 0.6, so 0.5. And now we can convert this into the probability that negative 1.833 is less than Z, because it's a Z number, is less than 0.5. Now what I always like to do is just do a quick sketch of what we're actually thinking about here. This is my dodgy looking normal distribution curve. There's the mean in the middle. You know that negative 1.83 is out here. And then 0.5 is up here somewhere. And we're trying to find that shaded area. So we always start off, we want to start with the highest one, so we go phi 0.5, and we're going to subtract from it phi negative 1.83, okay, and that will give us the shaded bit. But of course there's a problem because on your Z chart you actually don't have a negative value. So what are we going to do with that negative value there? Roll Party, what are we going to do with phi negative 1.83 recurring? Okay, now we do a bit of a lookup. Now how do I do this? Okay, phi 0.5. So phi 0.5 is this one here, 6915. Take away 1 minus now 1.833. So we go back here, 1.8. This is 1.8. 1.83 is that one there. And then 3, we've got to add 2 to the last one. So 0.9666. 0.9666. Okay, then plug that into the old calculator. I'm getting 0.658 to 3 significant figures. Or 6581. All right. Hang on. How do I get the? Where's that gone? Come back. Okay. All right. Does anyone have any questions about that? Feel free to ask. Yes, Thomas. Oh yes, yes, we do. Well done. Someone wasn't reading the question when they did this. How many? Okay, yep, so we're going to times it by 150. What does that give us? Who's got it? Yep, what do you got for night? I'll probably just round it to 79. 78, 79 birds. Yes, Rob Huddy. Okay, right, let's have a look. 6581 times 150, or 0.7, what's 0.7? Yeah, Vinayak, something's gone screwy there. Oh, that was magic. 98.7, so I'm going to say 99 birds. All right. The lengths of the eastern bluebirds are normally distributed. Got a mean of 18.4 and a standard deviation of sigma, so we don't know that. It is known that 72% of the eastern bluebirds have a length greater than 17.1. Find the value of sigma. Okay, so we've done a few of these kinds of questions before. So here's our normal distribution curve. This is our mean. And we've got this value somewhere down here, 17.1 centimeters, such that 72% are greater than that. Okay, so this area here represents 72% of the birds. Okay, whereas the mean is 50%, right? So what we do is we go to our Z table and find 72%. Okay, so you're looking inside the Z table here. So here's 72.91, that's too high. 71.9, here we go. Okay, so we're working with this guy here, which is 0.58, and we just need 10 on top of that to make it up to 72%. So we need this one here, which is a 3. So we want 0.583. That is 72%. So let's go back to our diagram here. But what I have found is the positive Z number that would be such here that 72% is below it. So that's 0.583, which means that this one here must be what? What is it? Yeah, Rob Huddy. Yeah. So now we can write our Z formula out. Negative 0.583 equals 17.1. Subtract our mean, which is 18.4, and then pop that over our sigma, and we rearrange the formula to find sigma. Now, when I do that, I got 2.23 to 3 significant figures. We are just about finished, which is good. Doing pretty well. I think we're on the last question. What have we saved to last? Oh, everybody's favorite. Oh no, not everybody's favorite. Still got one from this one. Okay. Random sample of 120 eastern bluebirds is chosen. Find approximation. There we go. What are we doing, Jess? Yeah, so this is going to be turning a binomial into a normal, okay? Because it's got this approximation business here, okay? So first of all, I'm going to write it as if it was binomial. So let's say it was binomially distributed, and we got 120, and we got 0.72 is our chance of it being greater than 17.1. Because they told us that in the previous question, right? 72% chance, right? Now we're going to change it to normal distribution. How do we do that? Whoops, wrong bracket. How are we going to do that, Tash? Yes, which is 86.4. And then what would I do, Tash, to find my variance? Okay, so times that by 0.28, which gives us 24.192. All right. And now we're trying to find the probability that how many? Fewer than 80. Okay, so y is less than, but we need to do our continuity correction. So Thomas? Correct, 79.5. Very good. And now we can find our z value. So z equals 79.5, subtract the mean, which we found up here. That's our mean. 86.4 over our standard deviation. What am I going to put on the bottom here, Tino? Yeah, good man. Okay, you remember the square root. That's perfect. And then we chuck this into calculator and get negative 1.403. Okay, which means that this is equal to, that z is less than negative 1.403. Hi, Nasi and Rihanna. We'll probably be another maybe 5 to 8 minutes-ish. Okay, so if we think of our normal distribution, negative 1.403 is out here, right? And we want less than that, okay? So we're looking at this bit here. So just using our symmetry, we could go, why don't we find phi 1.403 and then subtract that from 1, and that will give us this bit here, which, if I had drawn a decent diagram, would be equal to the blue bit. So let's go and find that now. So this one. Oh, what was I looking for? 1.403. Okay, so 1.40, and then we add a 3 to it, which is a 4 here. 9196. 9196, I think. So this is equal to phi negative 1.403, which is equal to 1 minus phi 1.403, which is equal to, what did I say? 1 minus 0.9196, I think is what it was. And then that gives us 0.80, 0.0, sorry, 0.0804. Yeah, Jess. Yeah, good. So when we're transferring from a binomial to a normal, we times NP. So what the heck? Okay. I don't know how that happened. So we go this one times this one. So N times P, and that's the mean of the normal. Are you happy with that? Yeah. All right, cool. And now let's see if we can whip through this permutations business. Okay, fun times. So we've got a group of 25 people, 6 swimmers, 8 cyclists, 11 runners, and each person competes in only one of these sports. And we're selecting a team of 7 people, from the 25 to take part. And so we want to find a number of different ways in which the team of 7 can be selected. If it consists of exactly one swimmer, at least 4 cyclists, at most 2 runners. Okay, so we just, first of all, we've got to think of the different ways we can do this. So we could have one swimmer. I can just do yes, can't I really? One swimmer, and what do we, at least 4 cyclists. 4 cyclists, so that's 5, and then we'd have to have 2 runners. Okay, that's one way of doing it. Now we have to have exactly one swimmer, so one swimmer. Let's say we have 5 cyclists, which will leave us with 1 runner. What else can we do here? We have to have 1 swimmer. We could have 6 cyclists and 0 runners. Is there any other way we can do this? I don't think there's any other way we can do this. I think this is it. So, how do we select the swimmers? Well, there's 6 of them, so that would be 6 choose 1. And then out of the cyclists, we're choosing 4, so there's 8 cyclists, choose 4 of them. And out of the 11 runners, we're choosing 2 of them. So that's them. And then probably want to write out what that comes to, which is 23,100, I think. Maybe just someone check me on that. So that's that one. The second one is same kind of scenario. 6 choose 1 because we're choosing 1 of the swimmers. Multiplied by 8 choose 5 because we're choosing 5 of the cyclists. And then 11 choose 1, which is times by 11 for the runners. And I was getting 3696 for this. The swimmers in the last one is 6 choose 1. And then 8 choose 6 for the cyclists. And obviously if we're choosing 0 runners, it's just, we don't need to include that. It's 11 choose 0, which is 1. And this gives us 168. And so the total number of ways should be, if I've got these numbers right, 26,964. All right. What else have we got here? For another competition, the team of 9 people consists of 2 swimmers, 3 cyclists, 4 runners, and the team members stand in a line for a photograph. Of course they do. How many different arrangements are there? Have you ever seen people line up, like 9 people just in a long line? Like, wouldn't they stand them in rows or something? How many different arrangements are there of 9 people? If the swimmers stand together, the cyclists stand together, and the runners stand together. Okay, this is pretty easy then, really. So we've got swimmer, swimmer, cyclist, 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 runner, 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 runner. Okay, now they all stand together. Now remember, they're different people. They're not duplicates, they're not clones. So obviously there's 2 factorial ways you can arrange the swimmers. There's 3 factorial ways you can arrange the cyclists. There's 4 factorial ways you can arrange the runners. And there's one more thing we need to think about here. What is the one more thing we need to think about? Good night. Yep, how many ways can we switch them around? 3 factorial. That's exactly right. And so we just chuck that into our calculator, and we get 1728. Last one? Last one. I feel like this is kind of fair. I'm pretty happy with these questions. Hopefully we get some like this. Okay. How many different arrangements are there if none of the cyclists stand next to each other? Now, this is a bit harder. Okay. So we don't... Who have we got? We've got a swimmer, swimmer. What do we have up above? Oh, yeah, 3 cyclists. Cyclist, cyclist, cyclist. Runner, 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 runner. Okay. So the cyclists don't want to stand next to each other. Okay. So what we could do is we can think of the other other people, right? We've got swimmer, swimmer, runner, 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 runner. And then there's different places that we can slot in the cyclists because the cyclists don't want to stand next to each other for some reason. So here's all of the places that we can slot in our cyclists, right? So there's 1, 2, 3, 4, 5, 6, 7. So there's 7 P3 places or permutations as to how we could arrange the cyclists in these spaces. Okay, everyone happy with that part? Because 7P3 means 7 times 6 times 5, right? So the first cyclist, there's 7 options for him. The next cyclist is 6 options for him. And the next one is 5 options for her, right? Okay, so that's them. Then we've got one more thing that we need to do. What's the one more thing that we need to do in this case? We've dealt with the cyclists. What do we need to do about the other Larrys? Deathly silence. Yes, Jess, what do you think? 5, 6. Yes, there's 6 of them, and so we can arrange them in 6 factorial ways. And for each of those 6 factorial ways, there's 7P3, 7 times 6 times 5 ways of chucking in the cyclists so that they're not together. Now, when you pop that into your calculator, what do you get? I actually haven't done this, so... Yeah, what have you got, Ropati? Okay. So there are 7 spaces. 1, 2, 3, 4, 5, 6, 7, right? 7 places that we could put the cyclists so that they're not going to be next to the next to each other, right? There's 3 cyclists. So the first cyclist has 7 places that they can go into. And let's say they go there, then there's only 6 options for the next one, right? And then 5 for the next one. That means 7P3. Or you could go 7 times 6 times 5 times 6 factorial. But 7P3 means placing 3 people in 7 possible places. And then the permutations. It's not talking about combinations because the order matters. All right, what does that give us? Does anyone have a result for that? Yes, Matthew. Does anyone else second that? Yeah. Okay. Cool. All right. I'm going to... I think I need to leave this there because I'm a little bit overdue for my Pure Maths 3 tutorial. I'll try and arrange another one a bit later on in the week so we can practice another one of these papers. Any last questions before we go? I see you've got one here, Mia. Would this way be easier, or could you do the total number of arrangements minus all the arrangements where the cyclists stand next to each other? Yeah, you could do that. You could do that too. All right. Any other questions? All right, team. Well, if you do have any questions or something comes up, you're stuck with something in your studies, just message me on ThinkWave. I think you can just reply to one of the messages there, and I'll answer it with a work solution or something. Okay. All right. Have a good evening. Pure Maths 3. All right. How are you going, Nasia, Rihanna? You doing all right?